right, so currently, what is the problem? So what my project is going to deal with clean rooms. So what are clean rooms? Clean rooms are controlled environments that are commonly used in many different industries, such as manufacturing and sometimes biotech and things like that. So what is a clean room? A clean room is a room in which everything is controlled. So the particles coming in and out are controlled. So they're used for specific purposes when there needs to be really good control of the environment. So the current problem is that the greatest cause of contamination of these clean rooms are currently actually people. So in the case in which a person would need to go in and work inside a clean room, 80% of the time the contamination would be caused by a human. Furthermore, for the proper supplies and the proper training to bring people in, it's extremely expensive. All right, so what is the goal of the concept that I will be providing you? So the goal is that the goal is to create a lower contamination clean room. So we want to maintain human control of the environment without necessarily bringing the human in to, say, contaminate it. But we also want to maintain efficiency. We want to maintain precision. We want to maintain human quality of work. So that is quite a difficult task, given that the human might never enter the room. And that is currently one of the best ways to. All right, so like right now, in order to do a specific task in the room, we would have a person go in, right? And that would contaminate, possibly. And what I'm aiming to do is just not bring the person in at all. So how am I going to do that? So what is closed loop? Closed loop is 4 parts. So it is a robotic arm, an apparatus that connects to your own arm, a camera and transmitter setup, as well as first-person view goggles. So what I plan to do is I plan to create a robotic arm that mimics the movements of your arm. So you'll be wearing a specific apparatus device on your arm. And as you move your arm, the arm within the room would mimic your movements exactly. And furthermore, to make it easier to control and to give you a very similar environment to the one that you would be experiencing, I'm going to have an eye setup and FPV goggles that will immerse you in the experience so that it is almost as if you are there working with your own arm. And that is the goal of the entire project. So first, on the robotic arm itself, it is created to mimic your arm specifically. Currently, I plan to have 6 servos on it, 2 servos representing a singular joint. So this right now is the concept of my shoulder joint. So this would represent your upper arm here, as you can if you can all see. I have 1 servo here that does this rotation that represents this movement of the arm, and 1 that does the up and down movement. So what we can do there is we can gain almost completely the same range of motion that you can if you were to just move. With just 2 motors, we would be able to gain completely almost the same range of motion that you can with your own arm. So with that, I intend to apply that to 3 joints, specifically your wrist, your elbow, and your shoulder, and eventually add fingers, but that is in the future. So currently with commercial servos, they aren't able to hold a very heavy load. Currently, the strongest ones that I have are 17 kilogram per centimeter servos, which on an arm length of about 30 centimeters is looking at about 500 grams of total weight on the arm. So in order to make this arm work as efficiently as possible, I've had to go through a lot of work designing and figuring out a method of saving weight while still keeping the robustness that needs. So what I settled on was a mix of acrylic, carbon fiber, and 3D printed materials in order to help with the mounts. All right, so next, the controller of the arm, the master apparatus. So what I intend to do with this is I intend to, it's going to be strap-on Velcro. And what's going to happen is I'm going to use potentiometers. And each potentiometer is going to measure the angle of the movement of my arm. And what that's going to do is it's going to translate that into an angle and send it over to our servos. And our servos are going to try to match that. All right. And for the eye setup, it's just going to be a basic camera and transmitter. So yeah, these are commonly used in things such as FPV drone racing. Very, very low latency. The quality is not great, but for the amount of lack of latency that it's extremely nice because it gives you that sense of real time, really there's almost no input delay that you can see visibly, which would give the user such a better experience and so much more precision and so much more control over their actual environment that they'll be working in. So the cost is not great, but comparatively, put into all of the work, all of the money that you've already put into creating the clean room, it doesn't add up to that much. It adds up to about $150 without the FPV goggles. The goggles would add about 100 more for a good pair. So what that means is that, what that does is, in comparison to something like just buying clean suits individually for people, a clean suit can cost upwards of $100 for the cheapest models. And that's per person, while my apparatus can be simply taken off and put onto another person such that they can use almost the exact same way. So yeah, and moving on to future goals is I intend to add pressure sensors to the fingers of the actual arm, so that you would get the feedback. You'd create almost like a sense of actually touching something, because you'd only be basing it off visual feedback. But if there were those pressure sensors, then maybe we would be able to notify you when you're actually making contact with something. Furthermore, eventually I would like to add movement to the robot itself so that it could be able to navigate the clean room. And I would love to apply this to a greater problem than just clean rooms, because I think that if this can be done, it could revolutionize the world, and especially in fields such as space, where it might be cheaper to just send a robot that could mimic your movements, instead of just sending an astronaut. Why risk someone's life when you can have the exact same functionality of a device up there doing it instead? Thank you.
Next one.
So I think it's a great idea, and you can apply this to, like you said, to space and other problems. One thing you'll want to think about for a clean room type of application is there is actually a lot of value in a human being there actually doing that, especially the dexterity of the fingers and the feeling of that, really that's why you would need a actual human being there. So getting the right kind of sensors and the dexterity with the finger movement will end up becoming actually one of the critical things there. But there are other applications where that may not be as critical, like for remote applications like you're talking about, that may not, so you'll want to better understand that problem to see if it's totally applicable.
Yeah, I like the idea very much. I think this could also find applications in, for example, robotic assisted surgical operations, right? Your concept could really extend the precision and I would say difficult to assess operations. So what I really like to suggest you is to think about some of those engineering design tools like Sketch or CAD models that could really give you more precise, I would say, concepts and dimensions that you can incorporate the sensors into the overall design story, right?